Have you ever been in the shower and wondered why your soap just won't lather up? Or maybe you've seen those chalky white stains on your faucets and thought, what is that stuff? Well, it's not your soap and it's not your cleaning skills. There's an invisible force at play called hard water, and today we're going to pull back the curtain and look at the science behind it. Yeah, you know exactly what I'm talking about. You're trying to get a good lather going, but the soap just feels slick and useless. Or you look at your brand new faucet, and it's already got that crusty white buildup. These aren't just random little annoyances, you guys. They are the classic calling cards of hard water. All right, so to figure out what's going on with our soap and our faucets, we have to start with the most basic question of all. What in the world is hard water? Okay, so at its heart, the definition is actually pretty simple. Hard water is just, well, it's water that's picked up a bunch of mineral hitchhikers on its journey through the ground. We're talking about dissolved mineral ions. It doesn't mean the water is dirty or bad for you. It's just chemically crowded. So who are these hitchhikers? Well, it mainly comes down to these two guys, calcium and magnesium. You see, as rainwater travels through the earth and over rocks like limestone, it just dissolves these minerals right up, and they tag along for the whole ride, right into your pipes and out of your tap. These ions are literally what put the hard in hard water. So here's the tricky part. These minerals are totally dissolved, they're invisible. Which brings up a really interesting question. How do scientists actually measure something they can't even see? I mean, it's easy to spot the crusty buildup, but how do you measure an invisible ingredient floating around in a glass of water? Seriously, it sounds like a magic trick, right? You can't just pour it through a filter and catch them. Nope, for this, you need some seriously clever chemistry to make the invisible visible. And the secret weapon for this little magic trick is a chemical with a bit of a funny name, EDTA. Okay, so what is this stuff? Just think of EDTA as a tiny molecular claw. It's programmed with one very, very specific mission, to hunt down and grab onto those calcium and magnesium ions. It's like a super specialized magnet that completely ignores everything else in the water and just goes after the two culprits causing all the trouble. And the process that uses this EDTA claw? That's called titration. Now I know, it sounds like a super technical lab term, but the idea behind it is basically a very, very precise counting method. You just add a little bit of your claw solution at a time, and you wait for a signal that tells you, yep, you've grabbed every last one. So let's walk through it. First, you take your water sample, and you add a special indicator dye, which turns the water, say, red. Then you start slowly dripping in that EDTA solution. As each drop goes in, those little claws get to work, grabbing all the free-floating calcium and magnesium. Now here's the really cool part. The second that the very last hardness ion gets snatched up, bam! The indicator dye is suddenly free, and the water instantly changes color from red to blue. And by knowing exactly how much EDTA it took to make that happen, scientists can calculate the precise hardness of the water. It's so cool. But wait, the story gets even more interesting. Just when you think you've got it all figured out, it turns out that not all hard water is created equal. And that brings us to the next big piece of the puzzle, the difference between temporary and permanent hardness. That's right. You know, depending on what other molecules the calcium and magnesium are hanging out with, the hardness itself behaves in totally different ways. This creates a huge split in how we classify it, and more importantly, how we treat it. So, on one side, you've got temporary hardness. This is caused by bicarbonates, and the big clue is right there in the name. It's temporary, because you can actually get rid of it just by boiling the water. That heat causes a reaction that turns the dissolved minerals into a solid, and that's the lime scale you find inside your kettle. But on the other side, you have permanent hardness. This is caused by sulfates and chlorides, and boiling does absolutely nothing to them. They are way more stubborn and need something stronger, like a water softener, to be removed. Okay, so this is all some fascinating chemistry for sure, but you're probably asking yourself, why does any of this really matter? Why go through all the trouble of measuring these invisible minerals? Well, as it turns out, the real-world impact is absolutely huge. You know, for us at home, it's all about preventing that lime scale from wrecking our pipes and appliances. But for industries, the stakes are way higher. Brewers, for example, need a very specific mineral profile to make the perfect beer. Factories have to prevent scale from destroying millions of dollars of equipment. Even the company that makes your laundry detergent needs to know, because they design their formulas to work differently in hard versus soft water. So it all boils down to this one simple idea.
We measure so we can manage. Whether it's you trying to decide if you need a water softener, or a factory tweaking a complex chemical formula, or a whole city making sure its water is safe. That little EDTA titration test is always the first, most crucial step. It gives us the power to control the invisible chemistry that's flowing all around us.
And that brings us right back to where we started, your home. The science isn't a mystery anymore. From the mineral hitchhikers to the molecular claw, you know the secrets behind that soap that won't lather. Which really just leaves one last question for you to think about. Just how hard is the water coming out of your tap?